the coverage of the cell towers needed to be able to confirm where those antennas at the top of the cell tower were pointing. The reason they needed to be able to confirm that was because if the coverage was not what they had sold and could be proven to not be there, then they needed to be able to move the antennas and prove that they moved them from this position to that position, and that's what caused the coverage to become real, to become correct. Now, you could have gone in here with a LiDAR scanner, too expensive, carting it from tower to tower to tower. Also, they wanted to use the folks who they already had on staff to be able to do the work. They didn't want to have to teach them a whole bunch of processing capabilities. So what we did was we used just a normal digital camera and took lots of photos and produced a three-dimensional model of this tower that's accurate sub-centimeter with imagery. Auto targets, of course, this is terrestrial photogrammetry. Perhaps some folks in the room have done this. The thing that's remarkable about it was just a formal digital camera. Obviously, you're collecting stereo pairs. You're doing a block, putting them together, and then modeling. And this modeling, as I said, is sub-centimeter accurate. And the reason for that was because the targets themselves had been tied together. The model must be correct not only in its attributes, and that little drawing right there is one of the braces, and it's being dimensioned to a 1/16 of an inch, but also its geospatial position, both relative and absolute. It wasn't just that, relatively speaking, from point to point on this cell tower, but absolutely speaking, this cell tower was in the right place. This is how. Continuously operating reference stations, which are part of a national network. That's how. One of the things I want to point out in my talk today is that there's no reason at all that we can't have geospatial positioning with imagery, since we have one of the world's most extraordinary national reference systems that are continuously operating. The data is available for free on the internet, and all one needs to be able to do is download it and process it. It's that simple. You can actually even do it in real time in most parts of the United States. In other words, if you've got on board with aerial, you fly it, you can actually correct in real time. You don't need to post-process. I don't want to go off into the realm of that too much, but I did want to point out it's not only relative accuracy, it's absolute accuracy. And why is absolute accuracy important? We're so used to the concept that if we're doing a cell in a particular part of the world and we're trying to do work in that area, as long as the scene can be relatively correct from point to point in our area of interest, we're done. However, to Laurie's point, when the scope of that work starts to get larger and larger and larger, it just doesn't make any sense anymore to be able to do that rectification in relative sense, but you also need to be able to do it in the absolute sense.